All right, I'm going to scoot that over a little bit. So we ended on ionic compounds and formulas and sort of determining the ionic compound based on the electron dot notation. So I'm going to go over here to covalent bonds now, because covalent bonds are a little different. Like I said, they're between nonmetals and nonmetals, so maybe kind of note that if you have the PowerPoint in front of you. And they are kind of cool because they are formed by sharing their electrons in order to obtain that octet rule. Basically what they do is they overlap the shared electrons and become neutral, basically electrically neutral that way. So yeah, it gives an example here of chlorine. But yeah, I like the hydrogen one. I was hoping that it would do that. Okay, I'm going to kind of draw that over here actually. See if I can pull that up a little bit. Okay, so if you look at hydrogen, and if you do a Bohr model of hydrogen, hydrogen's number 1 on the periodic table, so that means that it has 1 proton. And if you look at its mass number, it's basically like 1. It's 1.0079 or something. So most of the time, hydrogen has 0 neutrons. And how many outer electrons does hydrogen have? Well, what group is it in? It's in group 1. So that means that it has like 1 outer electron right there. Okay, well, what does it want to have? Well, here's sort of a trick. You might be inclined to say that it wants 8. Well, hydrogen and helium are kind of the only exception for that one. So hydrogen wants to be like a noble gas. Well, helium's a noble gas. But how many protons does helium have? Well, helium only has 2. And how many electrons can go in the outer shell of helium? So if you remember right, the first energy, let me kind of do one over here for helium. Helium's number 2. And that means if it's an electrically neutral atom, then it has 2 electrons floating on there. Well, how many can that first energy level hold? Well, how many elements are in the first row? Just hydrogen and helium. So the first shell can only hold 2. Okay, so that means that it's completely filled the shell. And that's sort of the definition for a noble gas, is that the outer shell is completely filled. So helium fits in that. That's why it's all the way on the other side of the periodic table. So hydrogen has 1 outer electron. It really wants to have 2 to be like helium because it wants to be like a noble gas. So if another hydrogen is floating along, so I'm going to erase this really quick. This is my helium here. And I'm also going to erase that because I drew my electron in a place that I didn't want to. I want to draw it right here, and I'll show you why. Because if another hydrogen is close to it, and it has 1 outer electron as well, if they kind of scooch close to each other and share, oh my gosh, I am so bad at drawing circles. Now, they're sharing these 2 electrons right here. So what happens is now they're okay because of that being shared like that. But they have to bond together in order to do that. So that's what it's showing in this picture over here. It's showing these guys being paired together. And it's basically just doing the same thing for chlorine. It's showing that chlorine has 7 outer electrons. And if it shares right here, these 2 bonding pairs, what it's pointing to right here, then this side of it has 8 and that side of it has 8. Okay, so they just take that one in the middle The one in the middle is the bonding pair, and that's what's allowing them to have that outer electron be like the octet, or have that outer 8 electrons. Okay, so hopefully that makes some sense to you. You can also have, with covalent bonding, you can have multiple bonds, and you can do all kinds of situations and still have 8 outer electrons. I would like to point out that a line means 2 electrons. Okay, so if you take this line and these 2 lines, that's like 2, 4, 6, 8. So that right here has 8 outer electrons, and then that right there has 8 outer electrons. So they share those double bonds in the middle to create an octet. You know, they could just have single bonds like this. They could have carbon and carbon, and then they could have, I can't really draw past my slide here, but they could have these single bonds here of hydrogen. And this would all be 8, and that would all be 8. They're still sharing, so they're still covalent, but it's just a single bond in the middle. So you can start to take out some of the hydrogens, and you can create, you know, more or multiple bonds in the middle. And the more bonds that you have holding them together, the stronger the bond is. It's harder to break those. That's like what your fats and stuff are made of. Some of your fats have single bonds, some of them have double bonds. The ones that have double bonds, those are kind of those bad fats sometimes. Okay. And then we're going to get into bond polarity. So I think for that one, I'm going to stop the video and start a